Right, so as for all of the questions, question 2, part B leads on from question A, and we already answered part A. So calcium carbonate and hydrochloric acid to give you calcium chloride, carbon dioxide, and water. So limestone is mainly calcium carbonate, so it's linking the fact that limestone is calcium carbonate to the equation above. It is weathered by acids. Notice we have an acid here, hydrochloric acid, in the air or in soil. In June 1990, a Year 9 class planned a long-term investigation into chemical weathering of limestone by acid in soil. They put limestone chippings of similar size in 3 nylon mesh bags. They buried the bags outside in soils of different pH. So we have sample A, which is pH 5, sample B, which is pH 7, and sample C, which is pH 8. Now again, this is linking back up to the chart you had earlier. So you have to know that pH 1 to 6 is acid, pH 7 is neutral, and pH 8 to 14 is alkali. So of the ones that we have in this example down here, the only one that is actually acid is sample A. And surprisingly enough, sample A is the one that actually weathers the marble chips in the bag. So we have to give a reason and quantify that in our little answer. Okay, so looking at the question just again before we write the answer down. So chemical weathering took place in sample A. The mass of the sample decreased. So why did the mass of the sample decrease? What happened? Why would it go down? What did we lose? Okay, so carbon dioxide gas is produced by the reaction of calcium carbonate, marble chips. So calcium carbonate or marble chips, same thing, in acid in the soil. So I've put that answer in twice by mistake, just take that one out. So the pupils predicted that the chemical weathering would not take place in sample B. Give a reason for their prediction. So the answer is soil B or C were not acidic. So 3. The chemical weathering did not take place in samples B and C. Some chemical weathering did take place in samples B and C. What would have changed the conditions in these soils to cause weathering to take place? So thinking about environmental things that can actually change, that can change the pH of the soil. So what can we do? What happens that could change the pH of the soil? So an answer could possibly be perhaps there was acid rain. Okay. So that's the end of that question.